So, good afternoon, everybody. Myself, Acharya Vishwan. Let's discuss NCRT questions. So, this is chapter 14th of class plus 2, which is semiconductor devices. So, let's begin with the questions. So, the questions are about the basic building blocks of elements, and about transistors, then about various devices used to control flow of electrons, vacuum tubes, vacuum diodes. Then there are questions based on theories of vacuum tubes, their limitations, then modern solid state semiconductor devices, then mobile charges, semiconductor devices, properties of them, cathode ray tubes, LCDs, galena, chemical formula, radio waves, bipolar junction transistor. And then there are questions on resistivity of metals, semiconductors, insulators. Then elemental semiconductors, compound semiconductors, example of inorganic semiconductors, organic polymers. Then most of conductors are from then futuristic technology of semiconductors. Then there are questions on elemental and compound semiconductors. Then questions are about electronic motion, then concept of energy bands, valence band, conduction bands, lowest energy, highest energy, outermost orbit of silicon and germanium. Then we have questions based on valence band, conduction band again. At 0 Kelvin, there are then energy band diagrams of different metals. Then there are different regions ABC and AEC and ED. Then there are questions based on energy gaps. Then there are questions based on holes and electrons, intrinsic and extrinsic charge carriers, total current. Then there are questions on energy band diagrams of semiconductor at 0 Kelvin. Then questions on ionization energy. Then there is a concept of doping. Then extrinsic semiconductors. Then pentavalent and trivalent dopants, which group silicon and germanium belongs to. Then we have N-type semiconductors. Then we have P-type semiconductors, forbidden energy gap, impurities, presentation of N-type, then P-type semiconductors. Then we have energy gaps for carbon, silicon and germanium, stannous, energy gap between AC and ED. Then we have questions based on electron and hole diffusion, then depletion layer, drift of holes, drift of electrons, thickness of depletion layer, drift current, diffusion current. Then equilibrium conditions of p-n junction. Then we have questions based on graphs of barrier voltage and representation of p-n junction under equilibrium. Then we have questions based on p-n junction diode, then biasing of diodes, graphs under biasing, forward biasing, reverse biasing. Then we have some theoretical questions based on that. Then characteristics of diodes, then p-n junction, dynamic resistance. Then we have the concept of transformer, half wave rectifier, full wave rectifier, their applications, graphs based on that, input and output in different cases. Then we have Zener diode characteristics, theoretical questions based on that, use of Zener diode. Then we have photodiodes, graphical variations, IV characteristics. Then we have LED, their roles, energy gaps, VI characteristics. Then we have different formations of different LEDs, use of them, gallium arsenide, etc. Advantages, disadvantages. Then we have the concept of solar cell. Then we have graphical questions on solar cell. Then we have IV characteristic of solar cell. Then we have band gaps for different elements. Then we have questions for silicon and gallium arsenide use. Then we have digital signal representation, logic gates, different logic gates, their truth tables, and graphical questions on that. And there are certain graphical questions on logic gates, input-output based questions, NOR gate, logical symbol. Then there are certain questions on the ICs, transistors. And there are questions on diodes, their use. There are questions on multi-integrated circuit, operational amplifier, digital amplifier. There are a total of 486 questions, and this is the answer key for that. So I hope it will prove to be boon to you in preparing NCRT physics for JEE Main and NEET. Thank you and have a nice day.